Hello, and thank you for joining me today. Here we are for my capstone project. This is James Williams from Trimble Tech High School. Trying to make the video here with my presentation attached. My stipend series for this year was From Rich Tasks to Mathematical Modeling. And so let's go ahead and get started. So I actually teach mathematical models as one of my subjects, and I felt like this particular stipend series would go really well with that. However, in order to kind of push myself a little bit, I decided to actually use my on-ramps pre-calc class as my target audience. Uh, the idea behind that was that it would force me to kind of go a little heavier, maybe a little more complicated problem. Some of the mathematical problems, the mathematical modeling problems, are great, but it's kind of lower level math sometimes. And all those projects would have been fine. And honestly, I've done several stipends on that subject. Uh, I decided this year to go with the on-ramps pre-calc class. And so we started the year looking at some very basic problems. I say basic, they were included in my resources, and they were some problems that could be done several different ways. And then the kids were forced to kind of think outside the box, like, okay, how do I do this? How do I know if I'm right? Things like that. Kind of stretched them a little bit. And so we did several examples or iterations, if you will, throughout the year. And the one we did most recently, that was kind of the culmination of some of those, was one that I called When Harry Met Sally. And so what this was designed to become an intro to parametrics and kind of dealing with the idea of implementing time as a dimension, if you will, or as a an extra variable in a particular situation. And of course, given my generation, I kind of tagged it with the movie. Most of the kids didn't know what it was, but I thought it was kind of a funny little nod there. So Sally was hit by Harry on her way to work. How do we mathematically represent the situation? And that was pretty much what I started with for the kids, and talked about, how would we show that, and how do we do that? How do we do that graphically? And I did not give them the word graph to start with. I kind of let them just talk about it. What do we do with that, and how do we represent that situation? And kind of give them some time to think. And then what I did was I had them make a list of questions. What would you need to know? So you have this idea of how you could represent it. What do you need to know? And then I had them compare with each other. And of course, these are smart kids. They start thinking about, okay, well, where did it happen, what time, and how fast, and how do we graph this, and or how do we draw this, or how do we represent it mathematically? Um, and so eventually, this leads to the idea of intersecting lines. And I asked them, would this work? Why or why not? And kind of some conversation there and debating, okay, well, yeah, sure, the two cars ran into each other, but like, do we have any definitions as far as where those cars are located and yada yada? And that leads us to the graphs. Okay, does this work? And honestly, a lot of them feel like this kind of representation on a graph of two lines intersecting is a really good idea, right? They're like, yeah, this works. We could show that the two cars would intersect because their paths intersect. And what we ended up doing, I had a conversation about the idea of, like, do any of y'all live close to each other as far as in the same neighborhood, things like that. We talked about the idea that they take similar paths to school, and they might even share the same road for a while on the trip to school. And yet somehow they managed to show up to school without running into each other, right? They didn't get into a wreck this morning. And so what's the difference? Why is it that they were able to be on the same line but not touch each other? And then that's where time comes in, and that's where we get to the idea of including time into the situation, and kind of opens the door for parametrics. And how do we represent that, and how do we talk about the fact that how fast is x changing with respect to t, and how fast is y changing with respect to t. And so then we go to, what information do we need to know, like, and I tried, shall we say, to keep this as simple as possible. But technically, you actually need quite a bit of information in order to represent this mathematically. Maybe there's a way to do it with less information, but this is what we went with. We had a coordinate for Sally, like, hey, this is where Sally lives at. And then we had a coordinate for the school she was going to. We mentioned where she was hit, kind of keep it vague. We just said it was halfway. So, of course, the kids after the midpoint, not a big deal there. And then we say what time she left home, and then theoretically what time she got to school. Now, we took some leeways here. We took some privileges with the fact that we're in a magic classroom with no stop signs or stoplights or traffic or anything else. We're not stopping for donuts. This is a constant rate. So it simplifies our model for us. We don't really have to worry about traffic flow or anything like that. We're just saying she was going constant speed to get to a certain place. And then we have where Harry lives and where Harry works at. And that's kind of all we have. That's all I give them to start with, right? And so also I do mention the fact that Harry, the same with Sally. Harry was going in a straight line at a constant rate. So what we can do is we can find the point of intersection. Most of them are okay with that. It takes them a little bit. And then of course we can find the speed for Sally. We know how fast she was going. And because we know the point of intersection and the fact that she was halfway, we can figure out that they actually intersect themselves at 7:30 or so, you know. What we don't have is we don't know what time Harry leaves his house. We don't know what time he gets to work. We don't know how fast he's going because of that. And so here's where the question comes in. We say, what time does Harry leave home if he drives 50 miles an hour? Now realize what this is doing is it's giving you the speed for Harry, but it's not telling you what time he left. And so you have to kind of like backtrack. Okay, well, how far did he go before he intersected her path? And what does that look like? And so we have where do they meet? It's finding the path. Y is representing the path with the basic y equals mx with b equations, not enough to verify a rec. Obviously, the two lines intersect. And then can we create equations x of t and y of t for each such that the given time t, x values match and the y values match, meaning that at whatever time they happen to crash, i.e. 7:30 in the morning, the x and y values would be the same when you input that t value, right? And so I went with 7 o'clock being the time that she started from her house. And so I went with that was t equal to 0. And so we had to kind of set like what is our zero time, right? Is our zero time midnight or whatever? Anyway, you don't care about the math part. You care about what that does. And really, because there's so many different things here, the kids really had to question and wonder, how do I do this? Because it was outside of their norm, and they had to kind of create the models here. Um, and so here's some other things that we talked about, like what all the cars on these roads have in common. So they share the roads. What would be different is the time in which they're there. I got a little ahead of myself on the slides there. And then what other situations could be modeled using parametric equations? And for me, my mind always just goes to projectile stuff, whether it's a golf ball or a rocket or ships at sea or anything like that. Because a lot of times I want to do t is time. So you could also do things like uh, how much money is on your check and things like that versus how much you pay in taxes. And your check could be X of T and your taxes could be Y of T, and they would have separate equations. Or you could really do anything, whereas time could be a factor. And in fact, honestly, time doesn't have to be the parameter. There could be a different parameter. It just happens to be the one that I kind of favor a little bit. And then here's kind of the conclusion, if you will. They were able to arrive at the desired result with a few prodding questions. Some needed peers to help guide them, but all seemed to understand the idea before we were finished. Quiz that covered this section has slightly above average scores, not radically, but slightly above. There seemed to be a more open feeling towards the problem than I expected earlier in the course, meaning that honestly, when we started in August and September and we were looking at some of these open-ended questions, they really, some of them would just shut down. They're like, I don't know. I don't know what to ask. I don't have enough information. There's just not enough. We just quit. And so it was nice to see towards the end of the year that they had got a little more open to the idea of, oh, well, maybe there's not one right answer, or if there is, maybe there's multiple ways to get there, and maybe I can get there, maybe I'm smart enough to get there. And that's always nice to see, is when that confidence comes and they're actually willing to try a little bit. In conclusion, rich tasks are tasks that require mining on the student's part. They have layers, several ways to solve different interpretations, and combine prior knowledge with new frontiers. When applied with rigorous content, they can yield fruit that is more potent than that of a more narrow approach. I'm excited to see the comments from teachers that my students will have next year, assuming they carry their problem solving abilities into the next subject. I also want to test many of my assignments to see how many of them could be completed with less provided information. And what I'm kind of excited about with that is, to me, if you can give them less information and have them still produce the same amount of stuff, it really is kind of taking some off of the teacher, some of the stress off the teacher, some of the worry off the teacher. And so the teacher really can more of just kind of facilitate and just kind of float around and help guide them instead of spoon feeding them. Because I think one of the things that we really need to in education get away from is spoon feeding. And so I think these rich tasks really help to decrease the amount of spoon feeding that's going on. All right. So I want to thank y'all for your time. Thank you for listening. If you have any questions, guys, my email is james.williams@fwisd. And I hope you enjoyed it. Thank you.